What I want to do in this video is give an introduction to the language or some of the characters that we use when we talk about geometry. And I guess the best place to start is to even think about what geometry means. You might recognize the first part of geometry right over here. You have the root word geo, the same word that you see in things like geography and geology. And this refers to the Earth. This refers, my E looks like a C right over there. This refers to the Earth. And then you see this metry part, and you see metry in things like trigonometry as well. And metry, or the metric system, and this comes from measurement. This comes from measurement, or measurement. So when someone's talking about geometry, the word itself comes from earth measurement, and that's kind of not so bad of a name because it is such a general subject. Geometry really is the study and trying to understand how shapes and space and things that we see relate to each other. So, when you start learning about geometry, you learn about lines and triangles and circles, and you learn about angles. And we'll define all of these things more and more precisely as we go further and further on. But it also encapsulates things like patterns and three-dimensional shapes. So it's almost everything that we see, all of the visually mathematical things that we understand can in some way be categorized in geometry. Now, with that out of the way, let's just start from the basics, a basic starting point from geometry, and then we can just grow from there. So if we just start at a dot, that dot right over there, it's just a point. It's just that little point on that screen right over there. We literally call that a point, and I'll call that a definition. And the fun thing about mathematics is that you can make definitions. We could have called this an armadillo, but we decided to call this a point, which I think makes sense because it's what we would call it in just everyday language as well. That is a point. Now, what's interesting about a point is that it is just a position, that you can't move on a point. If you were at this point, and if you moved in any direction at all, you would no longer be at that point. So you cannot move on a point. Now, there are differences between points. For example, that's one point there. Maybe I have another point over here. And then I have another point over here. And then another point over there. And you want to be able to refer to the different points. And not everyone has the luxury of a nice colored pen like I do. Otherwise, they could refer to the green point or the blue point or the pink point. And so in geometry, to refer to points, we tend to give them labels. And the labels tend to have letters. So for example, this could be point A. This could be point B, this would be point C, and this right over here could be point D. So if someone says, hey, circle point C, you know which one to circle. You know that you would have to circle that point right over there. Well, that so far it's kind of interesting. You have these things called points. You really can't move around on a point. All they do is specify a position. What if we want to move around a little bit more? What if we want to get from one point to another? So what if we started at one point, and we wanted all of the points, including that point, that connect that point and another point. So all of these points right over here. So what would we call this thing? All of the points that connect A and B along a straight, and I'll use everyday language here, along kind of a straight line like this. Well, we'll call this a line segment. In everyday language, you might call it a line, but we'll call it a line segment. Because we'll see when we talk in mathematical terms, a line means something slightly different. So this is a line segment. And if we were to connect D and C, this would also be another line segment, a line segment. And once again, because we always don't have the luxury of colors, this one is clearly the orange line segment. This is clearly the yellow line segment. We want to have labels for these line segments. And the best way to label the line segments are with its endpoints. And that's another word here. So a point is just literally A or B. But A and B are also the endpoints of these line segments because it starts and ends at A and B. So let me write this. A and B are endpoints. Another definition right over here. We could have called them aardvarks or end armadillos, but we as mathematicians decide to call them endpoints because that seems to be a good name for it. And once again, we need a way to label these line segments that have the endpoints. And what's a better way to label a line segment than with its actual endpoints? So we would refer to this line segment over here. We would put its endpoints there. And to show that it's a line segment, we would draw a line over it just like that. This line segment down here, we would write it like this. And we could have just as easily written it like this. CD with a line over it would have referred to that same line segment. BA with a line segment, with a line over it, would refer to that same line segment. Now you might be saying, well, I'm not satisfied just traveling in between A and B. And this is actually another interesting idea. When you were just on A, when you were just on a point, and you couldn't travel at all, you couldn't travel all in any direction while staying on that point, that means you have 0 options to travel in. You can't go up or down, left or right, in or out of the page, and still be on that point. And so that's why we say a point has 0 dimensions. 0 dimensions. Now all of a sudden, we have this line segment here. And this line segment, we can at least go to the left and the right along this line segment. We can go towards A or towards B. So we can go back or forward in 1 dimension. So the line segment is a one-dimensional idea almost, or a one-dimensional object, although these are more kind of abstract ideas. There is no such thing as a perfect line segment, because a line segment, you can't move up or down on this line segment while being on it. While in reality, anything that we think is a line segment, even a stick of some type, a very straight stick, or a string that is taut, that still will have some width. But the geometrical pure line segment has no width. It only has a length here. So you can only move along the line, and that's why we say it's one-dimensional. A point, you can't move at all. A line segment, you can only move in that back and forth along that same direction. Now, I just hinted that it can actually have a length. How do you refer to that? Well, you refer to that by not writing that line on it. So if I write AB with a line on top of it like that, that means I'm referring to the actual line segment. If I say that, let me do this in a new color. If I say that AB is equal to 5 units, it might be centimeters or meters or whatever, or just the abstract units 5, that means that the distance between A and B is 5, that the length of line segment AB is actually 5. Now let's keep on extending it. Let's say we want to just keep going in one direction. So let's say that I started A. Let me do this in a new color. Let's say I started A, and I want to go to D, but I want the option of I want to keep on going. So I can't go further in A's direction than A, but I can go further in D's direction. So this idea that I just showed, essentially it's like a line segment, but I can keep on going past this endpoint. We call this a ray. And the starting point for a ray is called the vertex. Not a term that you'll see too often. You'll see vertex later on in other contexts, but it's good to know. This is the vertex of the ray. It's not the vertex of this line segment, so maybe I shouldn't label it just like that. And what's interesting about a ray, it's once again a one-dimensional figure, but you could keep on going in you can keep on going past one of the endpoints. And the way that we would specify a ray is we would call it AD, and we would put this little arrow over on top of it to show that it is a ray. And in this case, it matters the order that we put the letters in. If I put DA as a ray, this would mean a different ray. That would mean that we're starting at D, and then we're going past A. So this is not ray DA, this is ray AD. Now the last idea that I'm sure you're thinking about is, well, what if I could keep on going in both directions? So let's say I can keep going my diagram is getting messy. So let me introduce some more points. So let's say I have point E, and then I have point F right over here. And let's say that I have this object that goes through both E and F, but just keeps on going in both directions. This is, when we talk in geometry terms, this is what we call a line. Now notice, a line never ends. You can keep going in either direction. A line segment does end. It has endpoints. A line does not. And actually, a line segment can sometimes be called just a segment. And so you would specify line EF. You would specify line EF with these arrows just like that. Now the thing that you're going to see most typically when we're studying geometry are these right over here, because we're going to be concerned with sides of shapes, distances between points. And when you're talking about any of those things that have finite length, things that have an actual length, things that don't go off forever in one or two directions, then you're talking about a segment or a line segment. Now, if we go back to a line segment, just to kind of keep talking about new words that you might confront in geometry, if we go back talking about a line, I was drawing a ray. So let's say I have point x and point y. And so this is line segment xy. So I could specify, denote it just like that. If I have another point, let's say I have another point right over here. Let's call that point z. And I'll introduce another word. X, y, and z are on the same, they all lie on the same line, if you would imagine that a line could keep going on and on forever and ever. So we can say that x, y, and z are collinear. So those 3 points are collinear. They all sit on the same line. And they also all sit on line segment xy. Now let's say we're told that xz is equal to zy, and they are all collinear. So that means this is telling us that the distance between x and z is the same as the distance between z and y. So sometimes we can mark it like that. This distance is the same as that distance over there. So that tells us that z is exactly halfway between x and y. So in this situation, we would call z the midpoint of line segment xy, because it's exactly halfway between. Now to finish up, we've talked about things that have 0 dimensions, points. We've talked about things that have 1 dimension, a line segment, or a ray. You might say, well, what has 2 dimensions? Well, in order to have 2 dimensions, that means I can go backwards and forwards in 2 different directions. So this page right here, or this video, or the screen that you're looking at, is a 2-dimensional object. I can go right, left, that is 1 dimension, or I can go up, down. And so this surface of the monitor you're looking at is actually 2 dimensions. 2 dimensions. You can go backwards or forwards in 2 directions. And things that are 2 dimensions, we call them planar, or we call them planes. So if you took a piece of paper that extended forever, it just extended in every direction forever, that in a geometrical sense was a plane. The piece of paper itself, the thing that's finite, and you'll never see this talked about in a typical geometry class, but I guess if we were to draw the analogy, you could call a piece of paper maybe a plane segment, because it's a segment of an entire plane. If you had a 3rd dimension, then you're talking about kind of our 3-dimensional space. In 3-dimensional space, not only could you move left or right along the screen or up and down, you could also move in and out of the screen. You could also have this dimension that I'll try to draw. You could go into the screen, or you could go out of the screen like that. And as we go into higher and higher mathematics, although it becomes very hard to visualize, you'll see that we can even start to study things that have more than 3 dimensions.